All right, so we'll be working on packet page 19. So if you could flip there. Um, each of these, part A and part B, are going to have 3 parts to them. So there's 6 total things we'll do on this page. We're going to show you how to do the first one from part A and the first one from part B, and then you'll do the other 2 in each. So in part A, they're saying we're growing at a constant rate of 500 people per year. So that means in the first year it goes up by 500 people. The next year it goes up by 500. The year after that it goes up by 500. Well, if you're going up by 500 every time, I want you to visualize what the graph of that would look like. Hopefully you visualized a line, so we want to think of a linear function. So we're going to be working with y equals mx plus b. So our m is what we're changing by each time. So for us, that's the 500 people per year. And your b is what you're starting with. Well, they told us up here it was starting with 5,000 people. So we'll be doing plus 5,000. So part I, we want to know how long it takes the population to double once. Well, if you're currently at 5,000, if you double once, you are now at 10,000 people. So to solve for x, we're going to subtract the 5,000 over. Which will give us 5,000. And that's equal to 500x. And we'll divide by 500. And that's going to give us 10 years. So what you will do in parts II and III, this one wants you to double twice. Well, if doubling once was 10,000, doubling again would be 20,000. So you'll do 20,000 equals in our equation. And in 3, if we double again, double 20,000, you get 40,000. And then you'll have to go through and solve. All right, it's going to be the same, double once, twice, and 3 times for part B. But if we go down here, we're increasing now by 5% each time. So we still have y equals, but this time it's exponential when you go by a percent. So we're starting with our 5,000. If we do 100% plus 5%, that gives us 105%. And when we move the decimal over twice, we get 1.05. Hopefully we're pretty good at that. Well, I guess up here, we should have told what x and y represented. X was years. And y was population. So we'll bring those down here as well. So in the first one, we were doubling once, so we'd want 10,000. Equals 5,000 times 1.05 to the x. And we're going to leave this one for you to solve because this is similar to what we have been doing recently. So you'll solve that one, and then in II, you'll again have it equal to 20,000. You'll go through and solve, and then in III, you'll set it equal to 40,000 and solve. So that's kind of a guide of what you'll do on this page.